Dear students, welcome to ECA 1 class. Today we will going to discuss Thevenin Theorem. So far, we have presented a number of techniques for circuit analysis. At this point, we will add one new theorem to our collection of tools that will prove to be extremely useful. The theorem is named after their author Emile Thevenin, a French engineer. Suppose that we are given a circuit and that we wish to find the current, voltage or power that is delivered to some resistor of the network, which we will call the load. Thevenin theorem tells us that we can replace the entire network exclusive of the load by an equivalent circuit that contains only an independent voltage source in series with a resistor in such a way that the current voltage relationship at the load is unchanged. So we say that any two-terminal DC network can be replaced by an equivalent circuit consisting solely of a voltage source and a series resistor. Now let's see what are the procedure to apply Thevenin theorem to any circuit. Let us consider a circuit in which we have to find the Thevenin equivalent for this shaded region. In the first step, remove the portion of the network where the Thevenin equivalent is found. In our case, remove RL temporarily from the network. So we have to remove that RL from the network in order to find a Thevenin equivalent circuit for that shaded region. So when we remove RL, the circuit looks like this. In the second step, mark the terminals of the remaining 2 points. So we mark A and B where RL exists. Now we have to find the R Thevenin resistance. In order to find the R Thevenin, set all the sources equal to 0. Sources equal to 0 means if you have a voltage sources in the circuit, replace it with the short circuit, and if you have any current source in the circuit, replace it with the open circuit. So here we have to find R Thevenin by short circuiting this voltage source. In next step, we have to find the value of E Thevenin, means Thevenin voltage. In order to find the value of E Thevenin, returning all the sources to their original position and finding the open circuit voltage between the marked terminal. We have to find the voltage at A and B point. In this case, you will see that the voltage across R2 is basically equal to that voltage which is across point A and B. After that, when you find R Thevenin and E Thevenin, draw the Thevenin equivalent circuit with the portion of the circuit previously removed or replaced between the terminal of the resistors. So here we place the Thevenin voltage and a Thevenin resistance. So this is basically the equivalent Thevenin circuit for this shaded region. RL is placed on its original position. Now, in order to understand the Thevenin theorem, let us take an example. In this example, we have to find the Thevenin equivalent circuit for the given network in the shaded region. We have to find the Thevenin equivalent for this region. So, in the first step, remove that RL road resistor because we have to find the Thevenin equivalent for this shaded region. When we remove RL, mark these points A and B. Now we have to find the value of R Thevenin. So when we are going to find R Thevenin, we have to set our sources to 0. In our case, we have only a single voltage source. So when we are going to set this source to 0, remove that source with the short circuit. So now you can see that this R1 and R2 are in parallel to each other. So R Thevenin is equal to R1 parallel to R2. When we substitute the values, we will see that 3 into 6 divided by 3 plus 6 is equal to 2 ohms. So the value of R Thevenin is equal to 2 ohms. In the next step, we have to find the value of E Thevenin. So E Thevenin basically is the voltage at this point A and B. It is basically an open circuit voltage at that point from where we remove that load resistance. Now from the figure you will see that this A and B point is parallel to this R2. It means the voltage on R2 is basically equal to the voltage at A and B point, which is equal to E Thevenin. So from the circuit we see that it is basically a simple series circuit. So when we applied voltage divider rule to this circuit, we will get that will give E Thevenin is equal to R2 into E1 divided by the total resistance of that series circuit. When we substitute the values of R2, R1 and E into this equation, we will get E Thevenin is equal to 6 volt. Now for Thevenin theorem, we just need the value of R Thevenin and E Thevenin. So from these two values, we will find the equivalent Thevenin circuit. So from the circuit, we will see that this is the value of E Thevenin and this is the value of R Thevenin. We replace this shaded region with this voltage source and series resistors. Now place the load resistance to its original position. Now you will see that the behavior of these two elements is equal to this whole shaded circuit. This is basically the Thevenin equivalent circuit for that shaded region. That's all for today. If you have any confusion, comment your question in comment box. Thank you very much.